Hello everyone, welcome to my talk, Java Threading Essentials. I'm Bazlur Rahman. I'm a Java user group leader, and I currently work as a senior software engineer at Contrast Security. So without further ado, let's get into the topic. So first question would be, what is a thread? All right. So all right. The idea is we write code in a file line by line, right? And it gets executed. To be able to execute a piece of code, it requires a execution environment. In Java, a thread is an execution environment. If a program has only one execution environment, then we call it this program a single-threaded program. Interestingly, in Java, um, we can create a lot of threads to run different parts of code of a program, and they can execute independently. So, and then if we can achieve that, we can call this program as a multi-threaded program. All right. In short, a thread executes a piece of code on a computer. So now the question gets to be, what are the some benefits of having multiple threads? So let's talk about that. The benefits of having multiple threads are enormous. Think about web applications that serve hundreds of users at a time. Then the question would be how it does it, right? Well, this answer is simple. It usually runs different requests on a different thread. So each user gets a thread to execute their request. Similarly, when I'm typing on a computer on a word processor, it does a lot of things simultaneously. One perhaps taking my inputs from the keyboard, and the other one perhaps checking my spelling. That way we can achieve various tasks simultaneously and the program gets responsive. If we have a single threaded program, then the problem would be I have to first give the input entirely and then program can check the spellings. That wouldn't be a nice experience, right? So that's some benefits of having multi-threaded program, right? So yeah, looks interesting, right? So next question would be, why do we need to learn threads? We could think of many more similar examples like what I have said so far, but let's think about the current computer architecture. The modern computer comes with multiple cores. For example, the computer that I'm using currently has a 16 cores. That means that at a point of time, it can run only 16 different things. If a single-threaded program runs on my computer, then it will be able to utilize only one core at a time, right? Then rest of the 15 would be just idle. We shouldn't waste the valuable resource like this. So we should be able to write our program in a way to utilize the available resources in our computer best possible way. On the other hand, if an application can do multiple things at once, we can achieve substantial progress as well, right? And our program can be faster. If we can subdivide the program into various independent units, and they can run in different cores, and that way we'll able to get faster results. All right. So sounds interesting. Looks to me a very powerful feature. All right. So now next question would be, do all Java programs have a thread associated with them? The answer is yes. Java was designed to have threads from the very beginning. If we just start a hello world program in a main method, it will execute through a thread, which is called main thread. Let's see an example. You can see this is a program, right? It has a main method, and what we're doing is over here we're just printing the current thread's name. So let's execute this program. Over here I have already written the code. So what it does is, thread.current thread, it's a method. It returns the thread that currently executing the program, and we can get the name of this thread from get name method, right? So let's run this program and see what it does. As you can see, it says the current thread name is main. That means this code and this piece of code is executed by a thread which name is main. So sounds like it is the answer is yes. I mean, all Java codes runs from a thread. So now the next question would be, how do I create my own thread? So we have seen that the code that we write in the main method gets executed by the main thread. However, we can have more threads to run multiple pieces of code. And there are two ways to creating your own threads. So let's see what are those ways. So first of all, we can create two threads by extending a thread, and secondly using the runnable interface. So let's see one by one. First, we're gonna use the first method, which is extending a thread. Let's see. So let me bring my ID over here. All right. So as you can see, I have created a main method already over here. What I'm gonna do over here is I'm gonna create a new class. I can create a new class over here. My new awesome thread, and extend threads. So threads is a class that represents the thread in JVM. It's Java lang class, as you can see over here. So we can just extend that, and its package is Java lang. So we don't need to import anything from Java lang. And what we have to do is, it's something we have to do. It's a must. All right. So over here, from this curly brace to this curly brace, whatever code we write will run using this thread. I mean, using instance of this thread. So it's a class. So if we create an instance of this thread, then this instance will be representing a new thread. So what we are gonna do over here is, let's say, run a for loop for I, and we're gonna run 10 times. And something we can write something over here. For example, hello world, right? So let's create an instance of this thread. So over here, we're inside the main method. We're gonna create the instance of this my awesome thread, and that's it. So I have created an instance of this thread. The only problem is it's not enough just creating an instance of the thread. We have to start the thread. So the way we do is we call this start method. So, and if we run this piece of code, which is we have written a for loop over here, and this gonna print a hello world 10 times, is going to run by a new which is my awesome thread. So let's run it. So as you can see, we have got this result. How can we be sure that this piece of code is executed by a different thread? So there is a way we can definitely see that. Let's see. So what I'm gonna do is I'm gonna append a string over here after this println, which is thread.current thread get name. So what I'm gonna do is over here, before running this my awesome thread, I'm gonna set a name. Set name. So if I run it now, so as you can see, hello world, and then it printed the name of this thread. So whatever name I provide over here is going to be printed over here. But if I don't do it, it will put a name of its own. For example, as you can see, it named a thread 0. So it's up to you. You want to name your thread or not? It's totally up to you as a programmer, right? So sometimes we put a name so that we can uniquely identify this is my threads, because in a Java program there are gonna be hundreds of other threads, and if we want to print a log or something, we definitely want to identify that this is the thread that I'm dealing with, and some other threads probably some other program is running, right? So to differentiate that, we can definitely put a name over here. So what are other methods? The other methods is we have a runnable interface. We can implement a class. So let's create a class. So let's name it my runnable, and implements runnable interface. Runnable is a functional interface, and it has one abstract method, and we definitely have to implement that, right? So let's do that. And over here, what I'm gonna do is I have a class with the same name. So let's name it my awesome runnable. Okay. So over here, I'm going to write some code, and the idea is whatever code I write over here, from this curly brace to this curly brace, is gonna be run. It's going to be executed by a different thread. So I can definitely put this code, and since I have already demonstrated that. Now if we want to execute threads with this interface, we have to do a little bit different way. So let me comment out that what we have to do is I have to create a thread, let's say T1, and then new thread. So what I have to do is I have to pass an instance of my runnable instance of a class that implements runnable. So first of all, I have to create that for my some runnable is equal to new, not that. So let's just copy it over here. So that's the instance of my runnable the class that implements the runnable, and I can pass this runnable through the constructor of the new thread, and then what I can do is var T1, that's an instance of the thread dot start. So it will do the same things, and these are the two ways we can do that. So since we didn't put a name for T1, it got a name which is thread 0, right? So these are the two ways we create our own threads. The other thing is, like I said, runnable is an abstract runnable is a functional interface because it has only one abstract methods. So we can, even without extending or implementing runnables, we can use a functional interface over here, which is, say, let's comment it out and create a new thread var T2 new thread, and we can directly put a lambda expression over here, and we can put any code over here, and that's gonna be executed by this T2. So if we want to copy this from over here, let's do that, and we can start T2 over here. So the idea is whenever we are gonna start a new thread, we have to call this start method, not the run method. So sometimes we do that mistake. We have a run method over here. We are not gonna do that. If we do that, this is not going to be executed by a different thread. It's going to be executed by the main thread. For example, if we comment it out, so now that we have a instance of thread over here, and we call this run method, right? And if we run it, what we will see is, it is executed by the main method, because main method is just from over here, right? This curly brace, and it ends over here. So if we call this run method of T2, so this run method is going to be executed by this main thread, and that's we don't want, right? We want this new thread, which is T2, to execute this piece of code. It should be a separate thread. And if we call this start method, that's how it happens. So we definitely have to be careful about that. So that's how we can create two threads, multiple threads. One is using the runnable interface, another is extending thread class. Most of the time we're probably going to use runnables, but it's up to you, the use case of you have, right? And as we go along, we're probably going to depend on other constructs that's available with JDK, and probably we're not probably going to deal with a lot of nitty-gritties, but as we go along, we'll be able to know that. Yeah, so that's how we are gonna create threads. So next thing is I'm going to show you a demo, which is going to be a demonstration of web server, how we can achieve the benefits of having multiple threads, and that's sort of demonstration I'm going to show you. So let's go into that. All right, for the demo, I have already created a class which is a single threaded web server. Let me explain what it does. What it does is it's wait for a client to be connected to this server, and it expects a web URL. It can be anything, and then it crawls down all the text available in this website and finds the most used keyword. That's what it does. It's simple. So let me explain a little bit. So over here, so we have created a server socket in a port, and it's waits to be connected by a client. That's what it does. It's simple. And inside the handle method, let me explain a little bit over here. So what it does is when we get it from the, it can be anything, any client. If it sends a text and we read this text using this code, and we have a service which is most frequent word service. Let me go into that. Simple class. It doesn't do a lot of things. What it does is it gets a URL and then it's validate, and then it scroll down using a library which is called zsoap, and then it finds all the words, and then it returns the most frequently used word, top word. We have a limit over here which is 5. So that's what it does. I'll definitely share this code base with you all, so don't worry about that. You can definitely look into those codes later. But the idea is, so it's a web server. It waits for a client, and if a client sends a web URL, compute the most frequent used word in that web applications and returns. That's all what it does. But the thing is, it can only do one thing at a time, because it's a single threaded web server. So let's run it. I'm just trying to print over here so that we can understand this is actually in fact running. Single threaded web server is running. That's the thing. Okay, so let's run it over here, and then it sounds like it started. So what I'm going to do over here now, I'm going to open a terminal, and then I'm going to telnet this. Okay, so look at this, right? So telnet localhost, and the port that I have started with is 222.222.2, and if I do that, so it's trying to connect, and it connected to the local host. And if I see over here, I can see it says client connected, right, with from a port. All right, so let's go into the terminal, and I'm going to put a URL over here. So let's say https Foojay.io. So Foojay.io. So now it should work, and it will take some time, and then it will return the most frequently used word. So sounds like the Java is used 67 times, OpenJDK used 36 times, Foojay 29 times. So yeah, these are the most frequent used word in that particular website. So if I do another website, let's say https bazlur.com, and then I'll get the most frequently used word from this site as well. So the problem is, now let's say if I want to open another client, let's say if another client want to connect to this web server, what happens? Telnet localhost 222, and you can see if I even type over here, let's say https bazlur.com, I don't get any response. The reason is this application server is a single threaded server, and it can handle only one request at a time. So since it's already connected with this client and it's not disconnected yet, so it will not be able to send a response to this other client, which is over here, right? So what if I if I disconnect it, then it will be able to connect it. As you can see, it immediately returns the result. So that's a problem of having single threaded web server. It can handle only one request at a time, but you can see the problem, right? Web application is supposed to handle multiple users at a time. So what I can do, I can just change a little bit this single threaded web server into a multi-threaded server, and that will be able to handle a lot of users. So what I'm gonna do is I'm gonna stop this program and change a little bit over here. So I'm gonna change it. So you can see this handle method, what it does, it gets a socket. I mean, when it connects to a client and it's create a socket, this socket is basically representing this connection, and then it delegate to this handle method. What if I create a thread, new thread, and inside the thread I can do a runnable, or I can do a lambda expression, doesn't really matter. So let's do a lambda expression over here, and I do put this handle method inside this lambda expression, and let's create a variable of it, which is my thread. And so, and what I'm going to do is I'm going to create a my thread dot start. So that's all I needed to make this entire program a multi-threaded program. So this handle method will be executed by a different thread each time a new client connect to this web server. So let's do that demonstration. If I run this program, so it sounds like it's running. So now I'm going to connect two client again. So first of all, let's connect again over here, telnet localhost, and over here I'm going to another terminal. I'm going to connect with another client. So what I'm going to do is over here, https Foojay.io. So I have got a result over here, and let's type over here as well, https Bazlur.com. So sounds like the both of them are currently working, right? If I open another terminal and do a telnet localhost 222, and if I type a URL over here, let's say https bazlur.ca, and still I can get a result. So sounds like now I have three clients working, and they are getting results simultaneously, and they are getting response, right? And if I see over here, you can see there is three client connected. So now you can see, right? It doesn't matter how many clients it gets, it will be definitely able to handle that. So these are the benefits of having multi-threaded program, right? You can definitely see that. So that's what I wanted to demonstrate. All right. So let's stop that. Okay. So it sounds interesting, although it also has certain baggage, which is when we are dealing with multiple threads, we have to be extra careful while we are gonna write program, especially if we share data among multiple threads. Let me give you an example how problematic it could be. So over here, I have a class, let's say counter, and it has a variable which is count, and what it does is whenever we call this increment method, it increment the value of this count, and then finally we can get the result count, right? So what I'm gonna do over here is I have created two threads. The counter is over here, it's an instance of counter, and we have created two threads. One is T1 and T2, and each of them will basically increment thousands time in this counter. So these are the two threads over here, and so idea is if I call this increment method thousand times, the value would be definitely thousands, and if another thread call this increment method thousands time, it should be another 1,000. That means the result should be 2,000, right? So that's the idea. And over here I have started the thread T1 and T2, and you can see a different thing over here, which is T1.join, T2.join. The reason is, if you remember, I said this main method is run by a main thread. So main thread starts over here, and then these are the execution of main threads, right? So main threads, what it does is create a instance of counter, and then it create an instance of T1, and then create an instance of T2, and then a main thread starts T1 and T2, and then it's hand over its job. So the increment and other things running for loops is a responsibility of other two threads. Now main thread is done with their job. So when a code block finishes, when a thread doesn't have any work to do, it finishes and it dies. So what it would have is, since if we don't do this T1.join and T2.join, main thread will come over here and it will print their result and it will die out, and while the other two threads still running, right? So in that case, we'll not get the actual output of this count variable, right? So what I have to do is I have to ask the main thread wait until the other two thread finishes this work, and that we can do with this join method T1.join. join t2.join. So yeah, let's run it. And the and as you can see, the result is not what we anticipated. So if we run it again, do you think we'll get a different result? Yes, we have got a different result. And if we run it again, and it sounds like we have a different result. So each time we run it, we get a different result, not the accurate one that we want, which is 2000s over here. It should be 2000s, but it doesn't. So the problem is the problem with this shared variable, which is the count value, variable. So although we have written one statement over here, but it's a compound statement. It's basically, first of all, it reads count and then count plus 1. So this is what it does, right? So first of all, it reads the value of count. For example, the value what it is now in this count variable, and then it increments it, and then it assigns this count. So now since we have two threads running, and two threads can be running in two different core, right? Two different CPU. So let's say this count variable is now 5. So and two threads read this count variable 5 and 5, both read this value 5, and then this piece of code is executed by another thread, and this piece of code executed by another thread. So both of them are going to increment 1. Now the value would be 6, and then both of the thread is going to put a new value to this count variable, right? So now both of has 6, right? And then although two thread incremented the value, but the value would be finally over here is 6. It should be 7 ideally, but it becomes 6 because the two threads read this value simultaneously and then update that. So this is a problem. This is one problem. There can be more. What would be the solution over here? So solution would be could be, which is whenever a shared variable read or write value from two different threads, we should put a lock, which is we call it mutual exclusion. So only one thread can read and write at a time. If we can achieve that, we can fix that problem. So in Java, what we have is we have a method, we have a keyword called synchronized, and if we can put that over these two places, this problem is going to be fixed. Sounds like it fixed. Now it doesn't matter how many times we are going to run this program, it will be always the correct accurate result. So now the question is, are you going to put synchronized in all the method? The answer is not. The reason is this is not going to solve our problem, because if we add too many synchronized, it's going to be working like a single threaded application, because only one thread can access this method. So it's a broad topic. And this I'm not going to be able to do the justice with this short window that I have. So the solution is you have to read a lot. I'm going to provide some resources for you where you can definitely get some idea. What I'm tried over here is give you an idea. So these are the essential things you definitely have to know. So all right, so let's go into the resources that I have, which is I have definitely a repository that's available publicly. You can definitely get this source code. There is an awesome book called Java Concurrency in Practice. It's called The Bible of Java Threadings. You can read that book. And besides, I have written a series on Java threading on the Foojay. If you go to this site, let me bring that site over here. As you can see, I have started a series on Java threading. You can definitely read that one by one, and then you will definitely able to know all this stuff, interesting stuff, definitely. And you can definitely tweet me if you have a question about Java threading. And I have a website which is Bazlur.com. You can definitely visit that website as well for other Java related resources. And that's all. Let me know if you have any questions. feel free to ask any questions related to Java threading. I'll try my best to answer as much as possible. Thank you.